Hello everyone, welcome to Mud Codes. If this is the first video that you're watching, then this is a continuation of the Calculator GUI where we created this GUI over here. This is the GUI and right now this doesn't have any functionality, but we're going to add it in this one and make it a little more presentable. So with that, let's get started. So currently the first thing I'm going to do is that if I press 7, 7 should appear on the screen, right? So for that, let's go to the result button, sorry, the result entry, and over here I will add text variable. So text variable is equal to output because it displays the output. So now I will create output over here. Output is string var, and I will also create input, which is like null right now. So once I've done this, I need to add functionality to the number buttons at least. So for that, I will come to 7 over here and add a command. So I'll add the command over here, which is lambda, and then click 7. And I'm adding 7 in quotes over here because it's a string. So now we have added the command over here, but we need to make something called click. So I'll create a function called click over here right on top. So def click. Basically, click will only work when someone clicks the button, and click will take an input B, which is the button. So over there we put the input 7 for click. So over here we will create global input because we need it everywhere, and input append with B. So as you saw in the button 7 over here, that the input I've given is 7. So when I click, it will take 7 as B and then add input B. So after I click 7, the input button will become, sorry, the input string will become 7. But this is not yet displayed on the screen. So to display it, we need to set it to output. So for that, I will set it to output. So output.set input. Now let's run and check. It's giving some error over here. Let's check the line. So over here it's giving an error for lambda. Okay, my spelling is wrong. It's lambda. So yeah, now it should work. So if I click 7, it's again giving an error. So this error is because output is string var, so I need to input string. So I could either convert B to string over here somewhere, or much better, I can just convert it to string over here. So I will add it in quotes. Okay, so the error over here right now is that I forgot to put braces over here as well. So now I hope it should work. Yep, it does. Let's click and hope it works. Yes. So 7 is working right now. Other buttons are not working because I haven't added the functionality yet. So let's do that. So I'll just copy this over here, this command, and add it to all the other buttons which I want to display, which is open brace, close brace. Okay, that is done now. So now if we run this code, 7, 8, 9, yep, all of them are working fine. Yes. So we have added functionality to all of them, and now we need to just make it a little more presentable. So right now when I click the button, it's just white. So let's add a clickable feature. So for that, for example, over here, I'll add active foreground and background. So active background, I'll add it as light gray, and I'll add active foreground as dark gray or just gray. So what this is going to do is when I run it and I press sign, it changes color. So when I press and hold, you can see the sign title, which was earlier black, becomes gray and the background becomes light gray. So this is a good feature to just add some like UI features. For that, we'll add this to all the buttons. Yeah, so all the buttons have a clickable feature now, and they do exactly what we've asked to. So they set an active foreground and background. I think this is good enough for the UI part, and also the numbers are being added up over here. Now what we need to do is assign the equal to feature just to add all of them together. So now to add the clickable feature over here, we'll first add a command. So command equal to and name it as EQ. Yep, I think EQ is, or we'll just name it as equals. So now we have to create this function. So we'll create it over here. F equals. So essentially what we're going to do over here is that whatever the input is, so global input, we'll first get it over here. So whatever the input is and whatever is set in the result tab, we need to compute it and display it over there itself. So for that, we will create a result variable, result equal to eval output. So eval is what actually does in this terminal over here. Like if I put 5 plus 5, it gives 10. But this operation that is being conducted here is what eval does over here. So we put result equal to eval output and then set output as result. So now if I run this and just add 5 plus 5 and hit on equal to, it gives us an error. Okay, probably because it's not an integer. So after this I need to make it into a string again. So res equal to str res. Now let's check. Hmm. Okay, so the error is not just the output part, it's the input actually. So I need to enter the input, not the output, my bad. So once I run this now, it takes 5 plus 5, which is the input, and adds it to 10. And now if I add something else, it displays 5 plus 5 plus and so on. But it should display 10 over here, right? It should aggregate this together. So we need to add that feature now. So for that, instead of having res over here, we will write input equal to string.res. So now when I run this, it gives 5 plus 5 equal to 10, then 10 plus whatever equal to, and so on. So now all the functions are working because it's basically just taking the string and multiplying it. So yep, and it does give decimals as well. Yeah, and also the brace feature. So now that this is done, let's add functionality to all the other buttons here. Now there are some small features which we need to add over here, like since we are using eval to compute everything, so 2 plus 2 works fine. But if I have something that gives an error, like if I just have 22 plus and I hit equal to, it's giving an error. Or if I divide 1 divided by 0, which is undefined, so it again gives an error. So for such errors, I can't have this displayed over here. I need to display something over here as well, right? So for that, I will use try catch block over here. So what try catch block essentially does, if you don't know it, is that it basically runs this in a try block, which is this, and if it gives an error, then it executes whatever I mentioned in this block, which is the catch or the except block over here in Python. So the except block goes like, maybe I'll just set output to invalid. Yeah, I'll set it to invalid output. Sorry, invalid input. And then I'll set input to like a null string. So now when I run this and I do something like 1 divided by 0, then it gives invalid input. And the next time I press something, it automatically starts fresh because I've given input as an empty string over here. So with that, we also need to define the C button, which is this, which should clear the board. So right now it doesn't do anything, but we need to clear the board as it's very important. For that, we can give a command called clear, and now we need to create a clear function. So def clear, and there's nothing much in clear actually. It just takes input and sets it to an empty string, and then the output is set to input as well. So we could have just set output to a null string, but that still wouldn't have made the input empty. Like, I'll just show it to you once. So if I set this to an empty string, then when I clear it, it does go away. But when I hit plus, it shows 2 plus 5 and so on. So if I clear it, it still remains in the memory for the input, which is something we don't want. For that, making input as 0 is important as well. So now if I run it and I clear it, so the next time I click something, it starts from scratch. So this is how we make the clear button. So now that we have the basic calculator working with all the arithmetic functions and braces as well, so now we need to do something, which is add the trigonometric and logarithmic functions. So for that, I'll come to sine first and add a command for sine. So command equal to sine. Now I have to create a sine function over here. So I'll just add all the advanced functions separately. So over here, def sine. And so what I'm going to do with sine over here is that I'm going to make it such that instead of having a sine bracket, like instead of having sine 45 entered like this, I will have it work like the equal to sign. So what I'll do is, if I enter 45 and I hit sign, it should display the sign of 45. Okay, so for that, it's pretty similar to equals. So I'll copy the equals code over here. And now the different thing that I'm going to do over here is that I'm going to add this one line over here, which is math.sign. So in Python and in most programming languages, you directly have this function in the math library. And yes, it won't work right now because I need to import the math library. So import math. Now that this is done, we can run it. So if I put sign of 0, 0 sign, it should display 0, which is correct. But now if I input 90-degree sign, so the input that I want to give is in degrees. So if I enter this, it should give 1, but it is giving this. That is because it is taking the input in radians, not degrees. So in order to get the answer in degrees, we need to create a function over here called 2 radians. Basically, I'm creating my 90 degrees that I enter into its equivalent radians. So, so what is 1 radian? I have to basically multiply it by pi by 180. So I'll multiply it by pi by 180. So basically 90 would become 90 into pi by 180, which is pi by 2, and that is the radian value. So I'll return x, and over here, just before I submit it to sine function, I will convert this to radians. So res equal to 2 radian res. And now if I convert this to sine, so sine 90 is 1, which is working perfectly. So similarly, I will create functions for cos and tan as well. And then I will create similar functions for square root and what was the other one? Log as well, but they of course won't have all of this. So this is for log. So this won't have the 2 radians part, and this will directly have math.log. And similarly for square root as well. Let's see if this works. Cos 90 is 0. Oh, sorry, I forgot to add the commands. Yeah, right. So, yep. So now let's check. 90 of cos. Yep, it's close to 0. So 6 into e raised to minus 17 is very close to 0. So it's 0. Basically, when it's converting it to pi by 2, the decimals are a little different. Let's check log of 2. Yep, it's correct. And let's check square root of 4. Yeah, so all the functions are working right now. So with that, the calculator is ready, but it's not completely ready because right now it's in a Python file, and every time I want to use the calculator, I need to run it. And if I want to share this calculator with all of you, I can't share this. Like, I'll have to share my Python file and you'll have to execute it in your Python editor or something else. But it's very inconvenient as an application. So now in the next part, we will learn how to convert this calculator to an executable file, which you can install on your computer and use it just like any other calculator app or any other app that you use on your computer. So let's see how that's done.